Okay, so we're going to talk about compositions a little bit more, but one of the main things we're going to do with compositions today is find the domain. And so that's not something we've practiced a ton. So on the back, we're going to fill in some notes, just some reminders about what restricts the domain and how you find it depending on what you're given. So the domain of a composition, there's two things you have to consider. So because the first, if we're doing f of g of x, g becomes the input. So no matter what happens in the simplifying of the composition, the domain of g has to be part of your domain of your composition. And you also have to look at the final answer to determine the domain of the composition. So just flip over on the back real quick. So just the functions we've talked about so far, we haven't talked about logarithms yet, so there won't be any logarithms on here. And we haven't talked about the trigonometric functions yet, so there won't be any of those on here. If we take out those, there's only two situations that make a function undefined. So what can you not do mathematically? Or if you tried to do it, your calculator would give you an error. Just two things. What about the zero? What can you not do with zero?
0 times 0.
You can do 0 times 0. You can't divide by 0. And so if you're doing these domain problems and there's ever an x in the denominator, you have to restrict the domain because that whole denominator cannot be equal to 0. So a lot of times you can just do it in your head. You can just figure out what is going to make the denominator 0. Sometimes it can be kind of complicated. Like we're going to do one that's a little complicated. So if you can't just figure it out in your head, then you set the denominator not equal to 0. So an equal with a slash. Set the denominator not equal to 0. So what is the other thing that you can't do mathematically? You might get an error in your calculator. Or get an imaginary answer. Square root of a negative. And so the other thing that's going to restrict the domain is if you have an x under an even root. All right, now these are varying levels of difficulty. We're going to do some of these that are pretty challenging, but don't be surprised if, like, on the exam, it's one that's easier than what we're doing. So if you want to find the domain and you have an x under an even root, you're going to set the radicand, which is what's underneath the radical, greater than or equal to 0. Because what's under there cannot be negative. It has to be greater than or equal to 0. So the denominator can't be 0, and the radicand has to be greater than or equal to 0. So two separate things you have to remember. Someone in my last class did it opposite every single time, so try to keep it straight. If not, flip over on the back and remind yourself. Okay, so let's do some of these. We are going to first find the composition. So on example 1, we have f is the square root of x minus 1, and g is x squared minus 8. So we're going to do f of g of x. So we're going to take g, which is x squared minus 8, and we're going to put it into f. So we're going to replace that x that is underneath the square root with x squared minus 8. And then we still have that minus 1 that we subtract from it. Okay, so then we need to simplify underneath there. And I know it's so tempting to try and just take the square root of x and take the square root of 9, but you cannot. I promise you, you cannot do that. I can show you numerically, like we could do it, and you could plug in numbers. It is not going to be equal. So if it was multiplication, definitely, but you can't separate a radical with addition or subtraction. Okay, so is this going to have a restricted domain? Definitely, because we have a square root, there's going to be a restricted domain. No, not always, actually. If this had been a plus, there's absolutely nothing you can square, add 9 to, and get a negative. Or there's no real number you can square, add 9 to, and get a negative. But there are lots of numbers that you can square, subtract 9 from, and get a negative. So this is the second situation where there is an x under the even root. So we're going to take that whole radicand, which is x squared minus 9, and we're going to say that it has to be greater than or equal to 0.
Is that the answer?
No. These are tough. We haven't solved a quadratic inequality in a long time, but they seem to kind of remember it last class. Do you guys remember doing this where we do the number line? We have to do the number line. So we need to find when this equals 0 by doing a little factoring. So there's going to be two values that make it equal to 0, negative 3 and 3. And because it's okay for you to take the square root of 0, we would do closed circles because it does include, because we have the or equal to, it includes those numbers. All right, so you have two options. We are going to test a number in each region. And last class I did it using the factors. I think it might be easier just to do it with the value, with the original. So it's up to you. If you like doing the little parentheses and doing it that way, that's fine. If you just want to take this number, square it. So if I square negative 4, what do I get? And subtract 9 from that, is that going to be a positive or a negative? Positive. So it's up to you. The other thing you do is you take negative 4, you put it into this factor. Negative 4 plus 3 is a negative. You put it into this factor. Negative 4 minus 3 is a negative. A negative times a negative is a positive. I think it actually might be easier to do it the first way on this problem. So when we plug in 0, if we go to this one, 0 minus 9 is definitely a negative. And then we put in 4, we square it, 16 minus 9 is a positive. All right, we're looking for positives here because we want greater than or equal to 0. All right, now I wrote all my answers in interval notation. You can do inequalities if you want to, but this one is going to go from negative infinity to negative 3, and we are going to include negative 3. And then go from 3 to infinity. All right, any questions on that? Okay, so we're going to do it the other way now. We're going to put G inside of F. I said that backwards. We're going to put F inside of G. Everything that I put into G, I'm going to square and then subtract 8 from it. So when I square that, I get x minus 1 minus 8. So it's going to be x minus 9. Right, and if this hadn't been a composition and you just wanted to find the domain of x minus 9, there would not be any restrictions. But because we have to, we have to consider the domain of what you put inside, because at one point, like at the very beginning of the problem, there's a square root, we have to restrict the domain. And so what I always do is after I do the problem, when I'm doing my domain, I look back at all my work. And if I ever see a square root or I ever see an x in the denominator, I know I have to restrict the domain. So for our domain, this one's going to be easier. We're just going to say that radicand, which is x minus 1, has to be greater than or equal to 0. So so x has to be greater than or equal to 1, which is from 1 to infinity. All right, what questions do you guys have? All right, the one I put on your worksheet is a little bit more difficult, so be careful. On it, these numbers are switched. It's like, it'll be something like 9 minus x squared, and you can't just switch them back to make it x squared minus 9. So just take your time on that one. I'll help you if you need some help for sure. Okay, so let's do one more of those. On example 2, f of x is 1 over x, and g of x is x squared plus 2x minus 8. And we want to put g inside of f. This is actually going to be super simple to do the composition part. There's no like simplifying to do. After you replace x with that expression, you're done. That's it. All right, should this one have restrictions on the domain? Yeah. So we see that denominator, there's some x's in there. So this is the type. Whenever there's an x in the denominator, we're going to say that whole denominator does not equal 0. All right, and then it's a quadratic equation. Not really an equation, it's a non-equation because it's not equal. But anyway, so these numbers need to multiply to get the 8 and basically subtract to get the 2. So it's going to be 4 and 2. All right, so there's two things x cannot equal, -4 and 2. Now, I've told you all I can't really see the multiple choice questions on the AP test. So it's possible that they would give the domain just like that. Just say that x can't be those two numbers. Those two numbers are not in the domain. But I just want to refresh your memory on how you do it in interval notation. So the very, very smallest number that is not -4 or 2 is going to be negative infinity. And we're going to go all the way to -4. But we're not going to include it, so we'll do a parenthesis. And then we do the U for union, and we pick back up on the other side of -4 and go all the way to 2, but not include it, and then go from 2 to infinity. All right, that's how your answers are on the answer choices, but like I said, it might be easier. You might just have to say that. All right, the other thing we're going to do is something I really like doing. It's kind of like solving a puzzle. And so it's doing the decomposition of functions. And so you kind of undo what the composition did. And so on example 2, we're going to decompose these functions. So we know that this was found by doing f of g of x. And so f is the outside function. So it's kind of like, a lot of times it's a parent function, but it's like whatever the function is, like the type of function. And then g is going to be the inside function. And so if you're looking at this, which one do you think is the outside, the square root or the x cubed? Definitely the square root. So f of x is the square root of x. Right? And then g of x is going to be whatever you would plug in for this x to get this. Yeah. Now, a lot of times there's more than one right answer. So I did only put one answer on your answer choices, but like on this one, just now thinking about it, f of x could have been the square root of x plus 1. And then what would g of x be? it would just be x cubed. So, like I said, there's more than one answer. I usually try to make my f of x just be a parent function if it's possible. It just makes it easier for my brain. Okay, so let's look at B. Might be a little more challenging. So what do you guys think f of x is? 1 over x. And then g of x should just be x squared plus 1. All right, what questions do you guys have? All good? Okay, super short lesson today.